Okay. So yesterday, saw a lot of balances that you tried to balance out. And why? Why do we have to balance an equation? Can't create, destroy what? Matter, yeah. And actually, since matter is always made up of little tiny atoms, you can't create or destroy the atoms. The atoms can't be created or destroyed. So that's why yesterday in the simulation, you could just put those, you were counting the atoms. Okay? So every atom I start off with, I have to end up with. That's the whole idea. Remember, this came out of Dalton's atomic theory. His idea about atoms, one of the things that made him think about it was that every time he did a reaction, the mass before and after was the same. What could explain why mass didn't change? Well, the logical explanation is because everything I started with is still there. So it's going to weigh the same at the beginning and the end. So chemical reactions had to be made up of something that didn't change. Okay? So all we got to do is get the same number of atoms of each element on both sides of the equation. Okay. So to summarize what you guys did yesterday, they actually, to balance an equation, it says rules, it's techniques, but I'll point out a couple of mistakes people make. First, write the correct formulas. That's why we need to be able to write formulas, because if you can't write formulas, if you write the wrong formula, if you write the wrong formula, you'll be unlikely to be able to balance it. Okay? So yesterday, they wrote all the formulas for you. Tonight, they'll write all the formulas for you. But then we'll move on to, okay, now here's the name. Here are the names of everything that fits together. You are going to have to write the formulas. Okay? Then you count the number of atoms of each type appearing on both sides. Did a lot of counting yesterday, right? Balance the elements one at a time by adding coefficients. And a good habit to get into is you're going to get lost in every little individual step. And if you make a math mistake in the middle, you may have fooled yourself. So get used to at the end checking to make sure it's balanced. Go back and count one more time. What happens is people stop too early. Say, oh, I got that fixed, and then quit, and there's still one that's messed up. But at fixing one messed up the other one that you had just fixed, which you didn't notice that. And here's things that are the wrong thing to do. Because they would make your life easier if they worked, but they don't. Okay? Never, never, never change a subscript to balance an equation. Subscript. Sub below, script written, little numbers on the bottom. Why not? Well, let's look at an equation. You balanced this one yesterday, right? Wouldn't it be easiest to balance this? You've got two hydrogens, two oxygens. There's only one oxygen on the product side. Wouldn't it be easier just to do that? Okay. What's wrong with that? Why is it wrong to just put that two there? Well, when I started off, remember it's a sentence. It says hydrogen and oxygen make water. But I put that two there, it no longer says hydrogen and oxygen make water. Now it says hydrogen and oxygen make hydrogen peroxide. Right? One of them you used to wash your hair, the other one you used to bleach it. They're not the same chemical, right? So if you change the formula, you're describing a different reaction. One of them is water, the other one is rocket fuel. Hydrogen peroxide was part of the fuel for the Germans' rocket. So H2O is a completely different compound than H2O2. You know, I thought that was all I had to say. But then I found people who were doing something I never thought of, so I got to talk about it now. They said, oh, I can't write a little number underneath? Well, I'll just write it big in the middle. Yeah. Somebody would put the 2 in the middle of NaCl. Oh, it's not a subscript because I wrote it big. That's not right. Formulas don't look like that. So do not do that. If you need 2 Cl's, you put the 2 in front of NaCl and you get the Nas along with it. It'll work out, trust me. Eventually they work out, as long as you got the right formulas. And that describes what you guys did yesterday over and over again, right? Because all you had to do was change subscripts, or change coefficients. Because that's the only thing you could change, was the coefficient. Okay? When you're writing it, you have to work a little harder at it. So let's do a couple examples and a review of how to use that table to do this. So silver nitrate and copper make copper 2 nitrate and silver. This says. Silver nitrate, AgNO3, and copper make copper 2 nitrate and silver. So as a reminder of what I showed you yesterday, I made a little table that had one side was reactants, the other side was products, and just listed every element in between. So I'm going to worry about Ag, worry about N, worry about O, and I have to worry about Cu. Okay. So I've got 1 Ag, 1 N, 3 O's, and 1 copper on my reactant side. Product side, there's 1 copper. That 2 gets distributed, so there's 2 nitrogens, and 2 NO3s would be 6 oxygens. And 1 Ag. What do I want to fix? See how the table it points out exactly what's not equal. That card. And you're doing that because you're trying to fix the NO3. And I can't fix it. I don't want to fix NO3. I want to fix N and O. Okay. So pick one, and oftentimes it fixes both. Okay. That makes sense. So, okay. Yep. So let's do it one step at a time. Okay. So that 2 there changes my N to 2 and my O to 6 like I want, but it messes up the Ag that was already fixed up. Get used to that. Fixing one often messes up another. Okay? Everybody see where I got the 2 N's and 6 O's. I distribute that to all the numbers multiply. Okay? And now I need to fix the AG on this side. I need to make it bigger. So I need to end up with a 2. What do I have to put in? I have to put a 2 so that silver is now a 2. And now my table says it's balanced, but see how I could get lost in the table versus the equation? So I want to go back to the equation and count it there. So I have 2 silvers, 2 silvers, 2 N's, 2 N's, 6 O's, 6 O's, 1 CU, 1 CU. Reminder of what you did yesterday, the table takes the place of that balance for you. That's what it's doing, taking the place of the balances for you. Okay, a couple of techniques that might save you some time. If an atom appears more than once on the same side, so there's 2 chemicals and it shows up in both. This often happens with oxygen and hydrogen. Oxygen and hydrogen show up in a whole bunch of stuff. You want to save that for the last one to balance. Because if you fix it early, the next thing you do is just going to mess it up. Does that make sense? Because it's in both. So if I fix it early by putting in a number, if I need to put a number in front of the other one, I've just messed up all the work I did. So don't try to fix, if it shows up more than once, leave it till last. Okay? And you're going to run into a situation where you're down and you got your table, and it's even on one side and odd on the other. And if one side comes in 2s, the other one comes in 5s. 2 and 5 are never going to run into each other unless you go bigger, right? So what you have to do is, if you're in that situation, whatever is in front of the first, whatever coefficient you've got in front of that first one, double it. It's going to force you to change all your numbers, but it'll get rid of that odd number so you'll be able to finish. This doubling thing gets rid of odd numbers. Last time I checked. Show you an example where both of those techniques come in. Okay. Okay. Demonstration. Well, here's a chemical reaction. Lead lighter. Okay. Fire is combustion, and what we did was, the fuel in here is butane, C4H10. You built that one a while ago. C4H10 plus oxygen. And when you burn stuff, it makes carbon dioxide and water. So let's balance this equation. C4H10 plus oxygen makes carbon dioxide and water. Carbon, only 3 elements to worry about: carbon, hydrogen, and oxygen on both sides. Because they better be on both sides or I've got a problem. 4 carbons, 10 hydrogens, and 2 oxygens on my reactant side. On my product side, 1 carbon, 2 hydrogens, and here's the tricky part. O shows up twice, so there's 2 here and 1 there, that's a total of 3. And can you see that I don't want to fix O right away? Because if I try to fix it first, if I work on the O, as soon as I start to fix the carbon, then I'm going to mess up the O I just fixed. Does that make sense? So because the O shows up twice on one side, I leave it till last. So if I'm not going to fix oxygen, then I need to fix carbon and hydrogen. So that says 4 carbons, so I'm putting 4 in front of CO2. And as soon as I write that number, I recount. That's 4 carbons and 8, and 1 more is 9 oxygen. There's 8 in 4 carbon dioxides would have 8, and then there's 1 in the water. Get that? Okay, still don't want to fix oxygen. So I'm going to fix the hydrogen by putting a 5 in front of H2O. That gives me my 10 hydrogens. But it makes my oxygen 5 here and 8 there is 13. So now I'm down to the point where I have to fix oxygen. If you look, it's 2 on the left-hand side and 13 on the right-hand side. What number can I put in front of oxygen and get 13? Can't do it, can I? Why not? Because one side is even and the other side is odd. So see how this is the situation we're talking about. I'm all the way down to the last one, and I can't fix it with a simple number because one side's even, the other side's odd. Okay? So what I do is I go to that first one, and whatever's in front, I double. Okay? It's going to change all my numbers, but it's going to change it in a way that gets rid of odd numbers. Okay? So I now have 8 carbons and 20 hydrogens. That's going to force me to change my numbers on the other side. Okay, something to get used to. You don't think about how many more you need. You don't think about how many extra. You say, I need to end up at 8 carbons. What does the number in front of CO2 have to be? Just get rid of that 4. It's not right anymore. What number does it have to be? It has to be an 8. So you're not trying to change. You're not trying to make the number bigger or smaller. You cross it out, replace it with a different number. Okay, we'll talk about simplified in just a second. Okay, because we'll talk about how this one will come out simplified. Okay, so I put that 8 there. That gives me my 8, and now it makes my oxygen 16 and 5, 21. But my hydrogens are messed up. I want that to be 20 hydrogens. So I need to get rid of that 5. What number has to go in front if it's 20 hydrogens? What number needs to go in front of H2O? Yeah, it's 10, right? That gives my 20 hydrogens, and I get 16 and 10, 26. So now I'm down to oxygen to fix again. What number can I write in front of oxygen that gets me 26? 13 works this time. See how that one switch gets me to the same spot, but I don't have the odd number anymore. Okay. The book talked about the last one, said reduce to the lowest ratio. So if all of those were divisible by 2, then I'd reduce it. If that was a 12 instead of a 13, I'd reduce it. But they all have to be divisible by the same number. Just like simplifying fractions. Okay? A fraction over a fraction over a fraction. You can do it, or divide all those the same way. That make sense? So just simplify, so if they're all divisible by the same number, reduce it. Otherwise, there's an infinite number of answers to every question. Right? Because you always do twice as big as the last guy did. Right? And that would still work.